Alright, let's begin with musical instruments when we talk about sound. There are two main types, well actually three types of musical instruments. The first type you've already seen, and that is for stringed instruments, where you have essentially a node, and here would be like the lowest, and in a fraction of a second it would go like this. So this would go back and forth. That would be, of course, your first harmonic. Your second one looks like this, and so forth. Okay, and you can draw the third and fourth. And again, just recalling, this is a half a wavelength, this is one wavelength, the next one would be 1.5, then 2, 2.5, etc. Well, we're going to deal with like pipe instruments. Okay, so a pipe instrument, or a hollow instrument there, would look something like this. We're talking about like flutes and saxophones and anything like that. Again, we're keeping it very, very simple. The first one we're going to look at is called open-ended. Okay, what this means is that both ends of the pipe are going to be open. Well, just a little reference here that you should know that the waves that get set up here, the standing waves, actually always end on antinodes at the end of the pipes. Okay, and then you have nodes in the middle, but they'll always be antinodes. So if I start here at the top, and the lowest one I can draw, the lowest wave I can draw is something like this. And essentially what's going to happen is it's going to just fluctuate back and forth and back and forth. Boom, 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 boom. It has to end on antinodes. Here's my node. Okay, so in this case, there's actually two antinodes and one node, unlike the music instruments. If you recall, the musical instruments always had two nodes, one antinode. Three nodes, two antinodes. Here it's a little different. Okay, two antinodes, one node. It's a little different. And when I look at this one here, you know, this would be my first harmonic. Okay, I'm going to draw the second one here. I'll draw it over here. The second one would look, let's see here, it goes down and then back up. It's going to look something like this. Okay, so it's just going to fluctuate. Now, if you look at this one actually is a full wavelength. Okay, whereas this one, this would be F2. So here's F1, there's F2, and F3 I'll just draw real quickly. F3 is going to look like this. It's going to go down, up, and down again. I'll just draw the second part of this, what it would look like. And so this would be F3. Now if you notice here I have half a wavelength, here I have a wavelength, here I have 3/2 of a wavelength. So it just keeps increasing like this. Okay, so you'll notice that little trend there. In terms of the formulas, okay, well, the formulas I gave on my sheet is basically L is equal to N lambda over 2, where N can be 1, 2, 3, etc. You'll notice that if I put a 1 here, I get lambda divided by 2. A 2, and I'll get lambda. A 3, and I get 3/2 lambda. So this formula does work out, and it actually does make sense. Just to refresh your memory here, if this is F1, the fundamental frequency, okay, let's say that fundamental frequency is 20 Hertz. What would F2 be? It would be 40 Hertz. It's double. What's F3? 60 Hertz. And just so you recall here, it has to be multiple integers of the fundamental. In other words, you won't ever get a second harmonic or third harmonic being some fraction. In other words, it wouldn't make sense to be 50 if the original was 20. Okay, so that wouldn't make sense. So it has to be equal integers up. There's an open-ended instrument. The other type on here that I wanted to show you was something called a closed-ended. Okay, and a closed-ended looks like this. Okay, it's closed at one end. Now it has to be a node over here. There has to be nodes on this part, and this part has to be an antinode. Well, the lowest one I can draw would look something like this. This is just going to fluctuate back and forth, this wave. And again, this only represents actually a quarter of the wavelength. The next one would look like this. Antinode. That was my original one, that's this one. But of course I have to go back to another antinode. And so in this one here, I actually have 3/4 of lambda. If I try one more, I'm going to get here, start on a node, antinode, antinode, antinode. I should make sure that's like this. And so in this case here, I actually have 1.25, which is 5/4 lambda. You'll see a trend here happening where I got a quarter, 3/4, 5/4. The next one would be 7/4. And in fact, my formula for this, okay, ends up being L is equal to M times 1/4 of lambda. Okay. The reason I'm writing M is to distinguish it from N, because M now can only be odd integers. M is equal to 1, 3, 5. I can't have 4. Okay, you can't have even integers of this, because it won't make sense. If it was 2, if I put a 2, then I'm going to end up exactly halfway, and it wouldn't be a node over here. That's impossible. It has to end on an antinode, which is why this can't form. So when you're working through this, just be aware here of this fact. And in fact, you can only have F1. You won't have F2, but you'll have F3 and F5. So if this were 20 Hertz, the next octave up in this instrument would be 60 Hertz. The next one, 100 Hertz, etc. Okay? So just being aware of that fact of how music instruments work.